Far, far from the warmth of the sun, in the cold, isolated reaches of our solar system, lies a world of breathtaking mystery, Uranus. A planet so distant and alien, it seems like something out of a dream. Its pale, icy blue surface, composed of swirling methane clouds, tells the story of a world constantly at war with the void of space, battling the forces of chaos in the heart of its atmosphere. But there is something more, something profound hiding beneath this tranquil facade, something that has captivated the attention of astronomers for decades. A storm, a colossal swirling vortex, one that has become a symbol of the unknown, the Great Dark Spot. Uranus is one of the solar system's two ice giants, along with Neptune. Though its size and composition set it apart from the rocky inner planets, what truly defines this distant world is its mysterious and violent atmosphere. Uranus is primarily composed of hydrogen and helium, but unlike its gas giant cousins Jupiter and Saturn, it harbors large amounts of icy compounds, water, methane, and ammonia, giving it a unique character. The planet's distinctive blue-green hue comes from methane in its atmosphere, which absorbs red light and reflects the blue-green wavelengths, coloring the gas giant in a soft, serene glow. Yet beneath this calm, the forces of nature rage in tumultuous and unpredictable ways. Perhaps the most intriguing feature of Uranus is its peculiar tilt. Unlike Earth, which spins upright, Uranus rolls on its side, tilted at a staggering 98 degrees. This bizarre orientation leads to extreme seasonal changes, where each pole experiences 42 years of continuous daylight followed by 42 years of total darkness. During these long years of daylight, the atmosphere is heated, creating violent storms that whip across the planet's surface, with winds reaching speeds far greater than anything seen on Earth. The first close-up observation of Uranus came in 1986, when NASA's Voyager 2 spacecraft made its historic flyby of the planet. As the probe sped past this distant giant, it took a series of images that would redefine our understanding of Uranus and its atmosphere. Among the many revelations, one stood out: an enormous, swirling storm in the southern hemisphere of the planet, so distinct and remarkable that it was dubbed the Great Dark Spot. Visible in the images was a massive, cyclonic storm system, a vast vortex stretching more than 13,000 kilometers across. To put this in perspective, this storm was larger than the entire Earth. It stood out in stark contrast to the pale blue atmosphere surrounding it, with its swirling, deep, dark core, a feature unlike anything seen on any other planet. The Great Dark Spot wasn't just a passing curiosity. It was a phenomenon of staggering proportions. Spanning over 13,000 kilometers across, about 4 times the size of the Great Red Spot on Jupiter, it was an enormous storm system, far beyond anything we typically observe in our solar system. But the question that immediately arose was this: what was driving this storm? How did a vortex of this magnitude form on a planet so far from the sun, in such an inhospitable, cold environment? Within the heart of this storm, winds roared at speeds of up to 900 kilometers per hour, faster than the speed of sound. To give you a sense of scale, that's faster than the strongest hurricanes on Earth, capable of causing catastrophic damage if unleashed on our planet. And yet, this was just one storm in the vast, turbulent atmosphere of Uranus. What made the Great Dark Spot particularly fascinating, however, was its dark color. Storms on other planets, such as Jupiter's Great Red Spot, are usually bright and noticeable. But the Great Dark Spot appeared, quite literally, as a shadow, dark and mysterious. The question arose, was it merely a result of the storm's immense size and swirling winds, or did something more profound lie beneath the surface? Ever since the discovery of the Great Dark Spot, scientists have been working to understand its origins. How did such a vast, powerful storm form on Uranus? What causes it to remain so persistent in an environment that should be inhospitable to such large-scale phenomena? One prominent theory points to the planet's internal heat. Uranus radiates more heat than it receives from the Sun, a characteristic that makes its atmospheric dynamics more complex than anticipated. The Great Dark Spot may be driven by an interplay of forces deep within Uranus's atmosphere. The extreme tilt of the planet causes its poles to experience intense periods of sunlight and darkness, which leads to temperature fluctuations that fuel violent storms. But it's not just Uranus's tilt. The planet's internal heat, produced by radioactive decay and residual heat from its formation, also contributes to the energetic convulsions within its atmosphere, driving the formation of massive storm systems. The storm's dark color might be linked to the planet's methane-rich atmosphere. As the storm's winds churn through Uranus's thick clouds, they could stir up deeper, darker gases and clouds, bringing them to the surface. This could cause the dark core of the storm to become more visible, as the methane-rich clouds block out sunlight in the heart of the storm. One of the most perplexing aspects of the Great Dark Spot is its seemingly ephemeral nature. After its discovery by Voyager 2, astronomers continued to observe the spot with Earth-based telescopes and the Hubble Space Telescope. But by the early 1990s, the storm appeared to fade away, as if it had vanished into the planet's turbulent atmosphere. However, the mystery didn't end there. In the early 2000s, the Great Dark Spot reappeared, albeit in a slightly different form. This raised an intriguing question. Was the storm merely a transient phenomenon, or is it part of a recurring cycle, an ever-evolving feature of Uranus's atmosphere? Some scientists believe that the Great Dark Spot's fluctuations could be a result of seasonal cycles on Uranus. As the planet experiences long periods of sunlight and darkness due to its extreme tilt, the atmospheric conditions might change, allowing the storm to grow, dissipate, and then reappear. The mystery only deepens as we continue to observe this elusive feature. Studying storms like the Great Dark Spot is not just about understanding one planet. It's about unlocking the secrets of planetary atmospheres across our solar system and beyond. The dynamics of Uranus's atmosphere, with its extreme tilt, unique weather patterns, and internal heat, could reveal fundamental truths about how atmospheres evolve on distant worlds. By understanding the Great Dark Spot, we gain insights into the forces shaping not only Uranus, but other distant exoplanets that may harbor similar storm systems. As we look to the future of space exploration, the Great Dark Spot remains a tantalizing mystery, one that will continue to fuel scientific inquiry for years to come. New missions, such as the proposed Uranus orbiter and probe, will travel to this icy giant to gather new data and solve the puzzle of its atmosphere and storms. These missions will measure everything from wind speeds to the chemical composition of the atmosphere, helping us unlock the truth behind the Great Dark Spot. Equipped with state-of-the-art instruments, these future missions will delve deeper into the dynamics of Uranus's atmosphere than ever before. For the first time, we'll be able to study the planet's most mysterious feature up close, perhaps revealing the hidden forces at work inside this enigmatic world. The Great Dark Spot of Uranus is more than just a storm. It is a symbol of the untold mysteries that lurk in the distant reaches of our solar system. A reminder that even in the farthest corners of space, beneath the ice and the cold, there are stories waiting to be uncovered. As we continue our journey through the cosmos, the great dark spot will remain a beacon, urging us to look deeper, to understand more, and to never stop exploring the unknown.